Hello, guys, and welcome to Aerominds Training Center. So, now we are starting with Principles of Flight, Chapter 4, and the Chapter 4 is called Subsonic Airflow. Now, we have already completed three chapters before, and now we are moving on to our fourth chapter, which is very important for our basic understanding of Principles of Flight. Now, we'll start with the first term, which is known as Aerofoil Terminology. Got it? Now, an aerofoil is any shape which can produce lift efficiently when air flows over it. Okay. I want you to focus on the word efficiently. Many objects can produce some lift if air is hitting them. All right. But an aerofoil is a specially designed so that air so that the lift is produced very smoothly, controllably, and also with very minimum wastage of the energy. Got it? Now this is why aviation we do not use random shapes. We only use the aerofoil for the shapes. Okay. Now in an aircraft, if you can imagine, the wing is the most common example of an aerofoil. Okay. Now whenever the an aircraft flies, air flows over the wing. You have seen the wing of an aircraft. The air flows over the wing. Okay. Now because the wing has an aerofoil shape, what happens, this airflow will create lift. Okay, which is necessary to lift off. Now, without an aerofoil shaped wing, an aircraft cannot fly in a controlled manner. It can fly, but not in a very controlled manner. Okay, now this is why we are understanding the aerofoil terminologies, and because they are very extremely important for our exam and also for our real flying. So we'll start marking, and I'm going to show the diagrams as well along with the uh, paragraphs. So, first is, what is an aerofoil? So, aerofoil is any shape that is capable of producing lift efficiently when the air flows over it. And in an aircraft, the wing is the most common shape example of an aerofoil. Now, I'm going to show the image of an aerofoil to you. So, this red image is how an aerofoil looks like. Okay, it looks like an eyebrow of a person, like this. Okay, now we'll move to the chord line. Okay, now the chord line is an imaginary straight line. Always remember, it is an imaginary straight line. Now, imaginary means that it does not physically exist. Okay, we draw it only for understanding and only for the measurement. Now, this imaginary straight line is drawn from the leading edge to the trailing edge of the aerofoil. Now, I'm going to explain what is a leading edge and what is the trailing edge. Okay, so if we can see that this is an aerofoil, this is an aerofoil. The front part, leading edge, is the front part of the aerofoil. Always remember, it is the front part, and the part that meets, it is the part which first meets the airflow. The air comes from here, and the part which first meets the airflow is known as the leading edge. Okay, now the trailing edge. So, trailing edge is the rear part of the aerofoil. As you can see, it is at the rear. So, it is the rear part of the aerofoil where the airflow leaves the wing. Okay, now so the chord line simply connects the front and the rear of the wing, okay, to the back of the wing in a straight line. Got it? Now this chord line basically joins the center of curvature of the leading edge and of the trailing edge. Got it? Now that sentence sounds very difficult, but no need to panic. The leading edge and the trailing edge are curved, and they are not very sharp pointed ends. Okay, now the chord line is drawn by imagining the middle of the curves joining them, like this. Got it? Now why is the chord line very important, if you ask? So because many important angles in the aerodynamics are measured using the chord line. Okay, many aerodynamic angles. Okay, now whenever you hear about the angle of attack, which is known as alpha angle of attack, or the angle of incidence, or any camber related measurements, the reference line which is used is almost always the chord line only. So this is very important for the concept. So remember this clearly for your exam. Chord line is the reference line. It is the reference imaginary line on the aerofoil. Okay, so we'll mark now. The chord line is an imaginary straight line which is drawn from the leading edge, which is the front part of the aerofoil, to the trailing edge, which is the rear part of the aerofoil. Got it? Now it joins the center of curvature of the leading edge and the trailing edge. Okay, and many important angles in the aerodynamics are measured using chord line. Okay, so it's very simple. Now we'll move to the chord. What is chord? So chord is simply the length of the chord line. That's it. Nothing more complicated than that. And in simple words, if you ask, so chord line is the distance which is measured from the. You can see it is the distance which is measured from the leading edge to the trailing edge. Okay, so if you take a scale and measure from the front of the wing to the aft of to the rear of the wing, the distance is known as the chord line. Okay, this distance is known as the chord line, as you can see here. Okay, and this line is known as the chord line, which is an imaginary line. Okay, now also remember that DGC sometimes ask very direct questions like what is chord, okay, or what is chord length. So do not confuse chord with thickness or span or anything else. Okay, chord is front to back distance, and not the top to bottom or not wingtip to wingtip. Okay, now we'll study about thickness and span also, but first we'll focus on the chord. So what is chord? The chord is the length of the chord line. Okay, in simple words, it is the distance from the leading edge to the trailing edge. And if you measuring it, so it is measured along the chord line from the leading edge to the trailing edge. That is it. Got it? So now we move to the angle of incidence. Okay, now, angle of incidence is actually it is the angle between two things. Remember that. Now, the first is the wing root chord line, and so wing root means the part of the wing which is attached to the fuselage. Now, suppose this is your aircraft fuselage. Okay, this is the wing. So this thing, this is known as the wing root. This is known as the wing root, and here is the wing chord. Here is the tip chord. Got it? So the first thing is the wing root chord, and so we take the chord line at the wing root, and the second is the longitudinal axis of the aircraft. Now the longitudinal axis is actually a imaginary, again it is an imaginary line only, that is uh, that is basically running from the nose to the tail of the aircraft. Suppose we have an aircraft, the line which is running from the nose to the tail of the aircraft is known as the uh, longitudinal axis. Got it? So the angle of incidence is the angle between the wing root chord line and the longitudinal axis of the aircraft. Got it? And this angle for the aircraft, this axis, longitudinal axis, is fixed. So and this is also fixed, so the angle of incidence will remain fixed, it will not change. Okay, the angle of incidence of the wing does not change during the flight, remember this. And the pilot cannot change it, pulling or pushing the control column or doing anything else will not change the angle of incidence. However, but some aircrafts, this angle may be variable on the tail plane. Okay, this that means that the tail plane angle can be adjusted in some designs, usually for the trimming purposes. Okay, now very important point for your exam and also for the understanding, the angle of incidence is set by the designer and not by the pilot. Remember this. Okay, the pilot has no control over it during the flight. No control, remember this. And many students are I have seen they are confusing the angle of incidence with the angle of attack. Now remember this clearly, the angle of incidence is fixed and the angle of attack changes in flight. Got it? So I'll show you the diagram first. So this is the diagram for angle of incidence. So this is the longitudinal axis of the aircraft, this is the chord line, wing root chord line, this is the angle. Okay, this is the angle of incidence. So remember, angle of incidence is the angle between the wing root chord line and the longitudinal axis of the aircraft. And this angle is fixed for the wing, cannot change in the flight by pilot or anything, and may be variable for some aircrafts on the tail plane. And this angle is set by the designer and not by the pilot. Got it? So now we'll move ahead. Now we'll talk about the mean line, or the also known as the camber line. Okay, now the mean line is basically it is a line which is drawn from the leading edge to the trailing edge only, just like the chord line, but its position is different now. Okay, now this line is located exactly midway between the upper surface and the lower surface, upper surface and the lower surface of the aerofoil. Now I'll show you a diagram it and see. It also shows the curvature of the aerofoil. So this is the uh, mean camber line. This will be the chord line. This curved thing will be the mean camber line. Okay, so because it is equidistant from the upper and the lower surface. Okay, and the difference between them is known as the camber. This thing is known as the camber. Okay, so I want you to imagine, suppose the thickness of the wing, the mean line runs exactly in the middle. Okay, and halfway between the top surface and the bottom surface, from the front to the back, which is from the leading edge to the trailing edge. Okay, now why do we draw this line? What is the significance? Now because it is showing the curvature of the airfoil, that is the reason. Okay, curvature means how much the wing is bent, how much it is bent or arced. Okay, now a flat wing like this, a rectangle wing, has no camber. Okay, it has no curvature. Now a curved wing will have a curvature like this. A curved wing will have some curvature. Okay, now we'll see this mean line, also called the camber line. Okay, it is a line which is drawn from the leading edge to the trailing edge, and it is located exactly midway between the upper and the lower surface of the aerofoil. It shows the curvature of the aerofoil. Got it? Now we'll now that brings us to the maximum camber. Okay, now maximum camber is the greatest distance between the mean line and the chord line. What I showed you here, this is the maximum camber. Okay, so in simple words, it is basically, it will tell you how much the aerofoil is curved and where the maximum curvature occurs. Okay, now this maximum camber is expressed as the percentage of the chord. It is expressed as the percentage of the chord. It is the greatest distance between the mean line and the chord line. Greatest distance, maximum distance. Okay, why maximum distance? Because here is the maximum distance, here it is not, here also it is not. So in the between somewhere where the distance is maximum, there only we'll measure it. So it is expressed as a percentage of the chord length. And for example, if the maximum camber is around 4%, it means that maximum distance between the mean line and the camber line is 4% of the chord length, like that. Okay, now along with that, its position is also given as a percentage of chord aft of the leading edge, because it is always aft. Okay, now that means we also specify how far from the leading edge this maximum camber is occurring. And it is important because the camber position will affect your lift, drag, and your stall behavior. Okay, so remember this. Maximum camber. What is maximum camber? The greatest distance between the mean line and the chord line. It is expressed as a percentage of the chord length along with its position as percentage of the chord aft of the leading edge. Okay. Now we'll talk about the types of camber. Okay. Now first is uh, positive camber. Okay, now in positive camber, the mean line, which is the camber line, stays above the chord line. Okay, this is the most common type of camber which is used in aircraft wings. Okay, so positive camber helps produce lift. If anyone asks what is the significance of positive camber, so it can produce lift even at negative angles of attack or very small angles of attack. Okay, so I'll show you a diagram for the uh, cambered aerofoil. So this is a cambered aerofoil. Got it? Cambered aerofoil. Like this. The mean line is above the chord line. The chord line is below, the mean line is above. So cambered aerofoil. Now next comes the negative camber. Now negative camber means the mean line or the camber line. Mean line is below. Okay. Mean line lies below the chord line. Okay, now this is rarely used in normal aircraft wings, but may be seen in some special applications. Only in some special applications. So, negative cambered aerofoil, like this. This is like this. Okay. Next is the symmetrical aerofoil. So, no camber, chord line and camber line are coincidental. Okay. Now, in the symmetrical aerofoil, what happens? There is no camber. That means that the chord line and the camber line are exactly on top of each other. Okay, and they are coincidental. The upper and the lower surface are like mirror images, like this, mirror images. Or even if you consider a rectangle aerofoil, then also it will be similarly. Okay, so remember all these 3 points. Positive camber, mean line lies above the chord line. Negative camber, mean line lies below the chord line. And symmetrical aerofoil, no camber, so chord line and camber line are coincidental. Got it? Now, a very important exam point is here. A symmetrical aerofoil produces no lift at zero angle of attack. Now, you guys, I want you all to think about it. Why is this happening? So, the answer is because there is no curvature to deflect the air differently above and below the wing. Okay, now lift is produced only when the angle of attack is increased. At zero angle of attack, there is no uh, lift generated. Okay, so what happens? I'll tell you in short what happens when the air reaches here. It gets divided into two parts. One is above flown, one is gone like this. So what happens? The speed, the as you can see, this distance is more than this distance. So the air has to cover the same distance like this within the. They have to cover more distance within the same point within the same time. So the speed over the air of the air which is above the wing has to be more. Okay, so that is the reason why the pressure reduces here and the pressure increases here, which causes the lift. Okay, so that is the basic idea of lift, and due to that, the lift is generated. Now, if we have a rectangle or a symmetrical aerofoil, okay, which has no camber, now both the airflows which are flowing over and under will have the same velocity, so there will not be a pressure difference at the zero angle of attack. When you increase your angle of attack, then only the angle will increase. Got it? Now we'll so remember, symmetrical aerofoil produces no lift at zero angle of attack. Got it? So now we'll talk about the thickness and the chord ratio. Okay, now, the thickness to the chord ratio is the maximum thickness of the aerofoil, which is expressed as the percentage of chord. It is the maximum thickness of the aerofoil, which is expressed as the percentage of the chord. So, if the maximum thickness of the wing is around 12% of the chord length, now then the thickness of to the chord ratio is around 12% only. Got it? So its position is also given as the percentage of the chord which is aft of the leading edge. Suppose this is chord. So this percent, suppose it is 12%. So like this here, 12%. Okay, aft of the leading edge. So here is leading edge, here is trailing edge. Aft is this, forward is this. Okay, so it will tell you about the thickest part of the wing, where the thickest part of the wing is actually located. Okay, now see the thickness and and its distribution of the aerofoil. They both strongly affect the airflow behavior. Okay, a thick wing behaves differently like a as compared to a thin wing. This is a thin wing. This is a thick wing. Okay, so they both behave differently. Okay, it influences the lift, drag, and stall characteristics. Okay, so for example, the leading edge thickness affects how smoothly the air flows and how the wing stalls. Okay, so if it is pointed like this, the air will flow smoothly. But if its leading edge radius is more, so it will have some problem. Got it? So remember all this. The thickness to chord ratio is the maximum thickness of the aerofoil. Now, what is a chord? Chord is this. Remember, this is the chord, and this is the thickness. Okay, so it is expressed as percentage of the chord. So its position is also given as a percentage of the chord aft of the leading edge. and thickness and its distribution strongly affects the airflow behavior and influences the lift, drag, and the stall characteristics, LDS. Okay, so now we'll talk about the leading edge radius. So first I'll show you the diagram, which will make the topic very easy. So this is the leading edge radius. This is the airfoil. Like this, it completes. Okay, so this is the leading edge radius. This is the leading edge. Here somewhere will be the trailing edge. Okay, now this thing, suppose this is a circle. This thing from the center to here will be the radius. So this will be the leading edge radius. I hope you got it. So remember, the leading edge radius is the radius of the curvature at the front edge of the aerofoil. Front edge of the aerofoil. Okay, so in simple words, it tells us how rounded or how sharp the front of the wing is. Okay, a larger or smaller leading edge radius has major effect in the initial airflow. Oh, okay. Now see, if the leading edge is too sharp, the airflow may separate easily. Okay, they might separate. And if it is more rounded, airflow can follow the surface more smoothly. Okay, so remember this has a major effect on the initial airflow, influences stall behavior and smoothness of the airflow. Now, it is directly influencing the stall behavior and the smoothness of the airflow. Okay, now the wings with the larger leading edge radius, the wings which have a larger leading edge radius, they are generally have gentler stall characteristics. Okay, which is safer for the training aircrafts. If you see, got it. So I hope you guys understood this. Now we'll move to a very important concept which is called the relative airflow. Okay, also known as relative wind or free stream flow. Got it? Now, relative airflow has three essential components, three essential characteristics of components, and all three have to be satisfied, and or else it will not be called relative airflow. Okay. Now, first is the direction. So first we'll see the diagram only, which will clear our concept. So this is an aircraft. This is the flight path of the aircraft. Flight path is where the aircraft is going. Okay, then in a level flight, this will be the relative airflow, the air which is coming relative to us. Okay, the air which is coming relative to us, we are going this side, air is coming this side. Got it? So now the relative airflow has three major components. First is the direction. We'll see about the direction. Now in the direction, basically the air is flowing parallel to and opposite the aircraft's flight path. Remember that it is flowing parallel to and opposite to the aircraft's flight path. That means that the relative airflow always comes from directly ahead. Okay, I hope you can imagine that opposite to where the aircraft is moving. It will always come from the front. So it follows the path of the aircraft center of gravity. Okay, and the direction the nose points is irrelevant. Even if the nose is pointing slightly up or down, uh, relative airflow is based on the actual flight path and not the nose direction. Okay, so remember this thing. Relative airflow has three essential characteristics. First is the direction. The direction is the airflow is parallel and opposite to the aircraft's flight path. Second is it follows the path of the aircraft's CG. Okay, where the aircraft is moving, and then the direction of the nose points where the nose is pointing is irrelevant. Okay, and the it is actually based on the actual flight path of the aircraft and not the direction. So remember that. Now comes the second condition, which is called condition. So the air must be undisturbed by the aircraft. That means that the pressure, temperature, and velocity of the air is not affected by the aircraft. Now this thing is very important. The relative airflow relative airflow is considered far away from aircraft. Remember this. It is considered far away from the aircraft before the aircraft is has disturbed it. Okay, so as we saw in this also, it is the airflow which is far away from the aircraft. It has not touched it yet. So remember this. Air is undisturbed by the aircraft, and the pressure, temperature, and velocity, the PTV, are not affected by the presence of the aircraft through it. Okay, now the third one, which is called the magnitude. Then now the magnitude is basically the speed. Okay, you can say the magnitude is the speed, or the relative airflow is the true airspeed. Okay, of the relative aircraft, of the relative airflow is the true airspeed. And this is a very common DGCA exam question. The speed of the relative airflow is always equal to TAS. Remember this, TAS, true air speed. Okay, so we'll mark this also. The magnitude or the speed of the airflow is true air speed. Got it? Now, listen carefully to this next point. Uh, if the airflow is not meeting all the three conditions, then it is not called the relative airflow. Okay, it will be called the effective airflow. Now, effective airflow is that airflow that is actually acting on the wing after being disturbed by the aircraft's movement and shape. So, effective airflow will be somewhat here, and relative airflow is here. Got it? Now we'll see different types of relative airflow. So suppose if the aircraft is climbing, the relative airflow will be this. Okay, if it is flying level, level means straight and level, not climbing and not descending. Descending means going down, not climbing, not descending. It will be straight. And if you're descending, the airflow will be like this. Okay, and this will be the relative airflow because it is away from the aircraft, it is not disturbed yet, and the magnitude will be TAS. So remember three things. Remember the three things. First is the direction, which is parallel and opposite to the flight path. Second is the magnitude. Magnitude is same as the TAS. Third is the condition. Now what is the condition? That the air has relative airflow must be undisturbed by the presence of the aircraft. The pressure, temperature and velocity must remain unchanged. Got it? So remember this, the last point also. If the airflow does not meet the three conditions, it is called effective airflow. Got it? Now finally we'll talk about the total reaction. Now total reaction is actually the resultant force. If anyone asks what is it, it is the resultant force. So it is the resultant force which is formed by all the aerodynamic forces which are acting on an aerofoil. That is it. Okay, so when air hits the wing, many small pressure forces act on it. Okay, when we add all of them together, the combined effect is called the um, total reaction. Okay, now the lift and drag here are the components of the total reaction. Okay, that means the lift and drag are not separate forces which are coming from different places. Okay, they are simply the components of one single force, the total reaction. Okay, and if they are resolved into vertical and horizontal components, so this will be lift, this will be drag. Okay, and these are relative to the airflow. Okay, we'll see a diagram for this also. See, we'll talk about the center of pressure later. That is the point where the lift is considered to act. Now comes the airflow. This is the relative airflow. This will be the drag. This will be your lift, and this will be your resultant. So this is your vertical component. This is your horizontal component. Drag, lift, total reaction. I hope you guys got it. So remember this. The concept is very important here. So total reaction is the resultant force, and it is formed by all the aerodynamic forces which are acting on the aerofoil, and the lift and drag are components of the total reaction. Okay, so that is it for the total reaction. Now we'll move to the center of pressure now. So the center of pressure is the it is a point on the chord line. Remember, it is a point on the chord line. It is not a line, it is not a area, it is a point, and this point is the location through which the lift is considered to act. Okay, that means when the lift is produced by a wing, when a wing produces lift, the it has to be considered from a point for acting. So we assume that the entire lift force which acts upwards is acts through this single point which is called the center of pressure. So we'll see this diagram and it will clear your doubt. So this is the lift force. Okay, so through this the center of pressure is considered to act. Okay, so remember this. And also in reality the lift is produced all over the wing surface and not just a point. Okay, not one point, which is the center of pressure, which I told you. But for understanding calculations and all for the stability analysis, we assume that the total lift is acting through the center of pressure only. Okay. Now the most important part about the center of pressure is that it moves its position with the angle of attack. Okay, now as the angle of attack increases or decreases, the center of pressure shifts forward or backward. Suppose it is here, it will move forward or backward depending upon the change in the angle of attack, and it moves along the chord line. Remember this, moves along the chord line. It is on the chord line only. Okay, now this movement forward or aft is extremely important because it is affecting your pitching moments. Pitching means up and down. Okay, it is affecting your pitching moments. And in DGC exam they may ask you whether CP is fixed or not. Is it fixed or not? So it is not fixed, it changes, and it changes with the angle of attack. Okay, so what happens at low angles of attack, what will happen? The center of pressure will be closer to the leading edge. So leading edge is here, this is the trailing edge. At low angles of attack it will be near this. Okay, and as the angle of attack increases, angle of attack we'll study here. So as it increases the angle, when the angle increases, what happens up to a certain point, it moves forward up to a certain point, and then it starts moving aft. Aft means below the wing, it moves starts moving aft. Okay, and so it will come forward as you increase your angle of attack. After crossing the stalling angle or critical angle of attack, it will start moving backwards again. Okay, which is actually near the stall. So this movement is one of the reasons the aircraft designers are careful about choosing the wing shape and also the tail size of the aircraft. So remember, the center of pressure is the point on the chord line through which the lift is considered to act. Okay, and it is flexible, which means it can move, it is not fixed, and it moves with the its position moves along the chord line and with the change in the angle of attack. Got it? So now we'll move to lift. What is lift? Okay, so lift is basically an aerodynamic force. I have already taught about the basics of lift in the previous videos. So it is an aerodynamic force, which means that it is produced due to the interaction of the wing of the air, which is with the wind and the aircraft. So the wind comes, hits the wing of the aircraft, and the lift is then generated. Okay, lift acts 90 degrees to the or perpendicular basically to the relative airflow. Relative airflow. Okay, so this is very important. Lift is not always vertical. Suppose the aircraft is climbing like this. So lift will not be like this, it will be like this. Okay, so lift is perpendicular to the airflow. So if the aircraft is climbing, descending, or turning, the direction of the lift will change accordingly. Okay, and but it is always at 90 degrees to the relative airflow. Remember this point. Now the beginners who are just started after 12th or have not flown, they always think that lift is acting upwards. That is not correct. Lift acts perpendicular to the relative airflow, and the relative airflow depends on the flight path. I hope you guys got it. We'll also see a picture of this. So this is the lift. Got it? So remember, lift is the aerodynamic force that acts 90 degrees or perpendicular to the relative airflow. Okay, and it is used to balance the force of weight, which is the acceleration due to gravity, which causes the aircraft to lift off the runway. Okay, and fly. Now let us talk about the drag. So drag is also similar to lift. It is also an aerodynamic force, and drag acts parallel and in the same direction of the relative airflow. This is relative airflow, remember this, and this will be the drag. So relative airflow comes from here, drag is also going here. So it is parallel and in the same direction of the relative airflow. Okay, that means that drag acts in the direction from which the air is coming. From wherever the air is coming, drag will act in that direction only. Got it? So because the relative airflow is opposite to the aircraft flight path is like this, relative airflow is like this. What happens? The drag will act opposite to the aircraft motion. Okay, this is why the drag will resist, why it resists the forward motion of the aircraft. That is the reason. Got it? So, again, remember for your exams, drag, that lift is perpendicular to the relative airflow, and drag is parallel to the relative airflow, parallel to and in the same direction as the relative airflow. Now, both are the components of the total reaction. Okay, and but the directions are confined with respect to the airflow only. Okay, not to the respect with the ground. It is an aerodynamic force acting parallel to and in the same direction of the relative airflow, which is opposite to the aircraft's flight path. Got it? Now we come to one of the most important and most tested topics in the aerodynamics, which is called alpha, or angle of attack. Okay, now angle of attack is also called the aerodynamic incidence. Okay, do not confuse it with the angle of incidence, which we have studied earlier. The angle of incidence is fixed, the angle of attack is variable. Okay, the angle of attack is the angle between the two things, which is the chord line. So first is the chord line, and second is the relative airflow. So remember this, both these things, chord line and the relative airflow. Okay, so imagine the wing moving through the air. Imagine a wing which is moving through the air. The air is coming towards the wing along the relative airflow direction, like this. Okay, now the angle between the airflow and the chord line is called the angle of attack. See this. This is the relative wind which is coming. This is the chord. This will be the alpha. This will be the angle of attack of your aircraft. So when you increase your angle of attack, suppose this moves here like this. So the angle of attack has increased. So this will be the angle of attack now. So if anyone says increase your angle of attack, means you will pitch up. Pitch up. Okay. So remember this, that the angle can change continuously during the flight. When the pilot pulls back on the control column, the angle of attack will increase. Angle of attack will increase. And when the pilot pushes the control column forward, the angle of attack will decrease. Okay. Angle of attack directly affects your lift. Okay, and if the angle of attack is increasing, lift will increase up to the critical angle of attack, which is called m crit, which is called alpha crit. Okay, critical angle of attack. Now if the angle of attack decreases, the lift will also decrease. Okay, lift will decrease, and this is why the pilots control the altitude and climb primarily by controlling the angle of attack only. Once you start flying, you will know, and if you have not yet, you guys can see that. So we'll see about this. So angle of attack is called the aerodynamic incidence, the angle between the chord line and the relative airflow. And now we come to the effective angle of attack. Now effective angle of attack is slightly different but very important for your understanding the real airflow. Okay, now effective angle of attack is that angle between the chord line and the effective airflow. Okay, now remember earlier we have discussed about the effective airflow. We have discussed about it. So effective airflow is that airflow that is actually acting on the wing after being disturbed by the aircraft's motion, downwash or any wing shape. Okay, so the effective angle of attack is the real angle which the wing will experience. Okay, which the wing will experience, and not just the geometric angle with respect to the free stream relative airflow. So remember this. This will be your effective angle of attack. This effective angle of attack, and this will be with respect to the relative airflow will be your angle of attack. Okay, so remember that the effective angle of attack is what truly determines how much lift is being produced at that moment. Okay, and also remember to this also remember this last line, uh, which is very important for flying also and also for the exams. Angle of attack is controlled by the pilot. Okay, speed does not actually directly control the lift. The power does not directly control the lift. The pilot controls the lift primarily by changing the angle of attack. Remember that. Okay, so if the pilot who is flying, if he increases the angle of attack, the lift will increase up to the stall. And if the pilot decreases the angle of attack, the lift will decrease. Okay, this is the fundamental concept which is behind the climb, descent, slow flight, or any stall recovery. Okay, so I hope you understood this. So angle of attack is controlled by the pilot and directly affect the lift. So that is it for this part 1. We'll continue the next part in the upcoming videos. We are planning to complete this chapter in 3 or 4 parts. It's a lengthy chapter, but very easy and very scoring. And it also is very interesting. So remember what we have studied. What is aerofoil? Any shape that is capable of producing lift with relatively high efficiency. In an aircraft, wing is most common example of the wing, aerofoil. Chord what is chord line? So imaginary straight line which is drawn from the leading edge to the trailing edge. Then comes, it joins the center of curvature of the leading edge and the trailing edge. Then comes what is chord? So it is the length. Angle of incidence, it is fixed, measured between these two things, and may be variable for the tail plane of some aircrafts. Then what is the camber? So we saw it is the difference between the mean line and the chord line. Then maximum camber, greatest distance between them, the mean line and the cable line. Then three types of cambers: positive, negative, and symmetrical. Thickness to chord ratio, then we saw. Then the leading edge radius, the diagram also we saw about the leading edge radius. Then the relative airflow and the three conditions for it, three characteristics. Then comes the total reaction. Then we saw the center of pressure, the point on the chord line where the lift is considered to act. Okay, whereas but in real life it is acting on the whole wing, but for the studies or mathematic problems we considered it to be acting on a single point. Then lift, now aerodynamic force 90-degree to the relative airflow, drag parallel to and in the same direction of the relative airflow. Then the angle of attack, which is the also known as aerodynamic incidence, angle between the chord line and the relative airflow. Then the effective angle of attack, okay, between the chord line and the effective airflow. Now angle of attack is controlled by the pilot and uh, directly affect the lift. Got it? So I hope you guys understood this video or understood the topics. And till then, goodbye. I'll see you in the next one. And if you have any doubt, or if you are not very well understanding the way with I'm teaching, you guys can give me suggestions so that I can dwell myself according to you. So thank you guys and take care.